Hi, it's Gadget UK here again, back with a Commodore repair, an Amiga 500 power supply. So yeah, it's a little bit yellowed, well, very yellowed. Cables seem okay. Let's have a look at the connector there. Yeah, that looks okay. Need to check the fuse in there. But before I do anything, I'm going to take the lid off before I power this up, just to see what the state internally of this is. Because you never know, someone could have been tinkering with this. There might be a flowing live wire in there, or you know, all sorts of things could be going on with this, because it was described as faulty. So there we go, that's all 4 screws out. Let's just lift the top off. So yeah, it's looking a little bit dirty. You can see what you get here. Typically these resistors here, the area around that obviously gets pretty baked from the heat. More often than not, these resistors burn up actually. It's probably going to need recapping this. It's got its original old crusty electrolytic caps. None of them are domed. I don't see any signs of anything having you know, expired, burnt out, exploded, etc. But we'll do some sanity checks on this, I think. We'll start by checking the fuse down here. So we'll switch the meter into continuity and diode test, and we'll just test it. Yeah, and the fuse you can't quite see is just down here. Yeah, the fuse is okay. So we'll test the mains fuse. I am not sure how this comes out here actually. Does it come like that? Yeah, there we go. Can't get the darn thing out. Yeah, so it's got a correct size fuse in there, 3 amp. Yeah, that fuse is okay. So the fuses are okay. So on continuity test again, you know, diode test, I'm just going to test the main switching transistor over here. We're just going to measure between, you know, the pins, just to make sure we don't have a short. I mean, with fuse would have blown if we had a short there, but nevertheless I will just test that. Yeah, I think we're okay. You can see the bridge down here. We've got 4 diodes. So again, on the diode test, so again on diode test, we'll do this, the top one here. Can you see there's a band on the right hand side of that first one there? That's the cathode. So positive on the anode, negative on the cathode, and you can see on the meter there, .548, that's correct. We're just making sure we haven't got short more than anything. Yeah, 548, I'm just checking each one that way, with the red lead on the side without the band, the negative on the side with the band. So our bridge is okay. So, you know, as the AC passes in here, it's rectified by those 4 diodes to give you a DC voltage. It's probably smoothed by this big cap at that point, and it's going to pass into this switching transistor here. And that switching transistor is going to switch at a very high frequency, you know, like 100 kilohertz. There'll be a feedback loop there, so it can, you know, alter the width of those pulses there, if you like, and the frequency of them. But ultimately it goes into this transformer here, and then the output side of the transformer, you know, the second phase or stage of the transformer, you got the, you know, lower DC voltages coming out here. You've got an opto isolator there, which is used to well, isolate the primary from the secondary. But ultimately I think that's where the feedback signal is going to come through. So we could have a failed opto here. You know, some of these little transistors and things could be faulty. The main transistor could be faulty. It's not shorted, but it could be. You know, something could be open circuit there or something. You never know. It might just work. But I mean, I've seen enough there now to make me think it's not going to explode. Let's just measure these 2 resistors down here. Let's just see what state those are in. Yeah, you can see that 47.1 ohms, the one on the right, the one on the left. I'm guessing it might be the same size. Yeah, 47 ohms. So even those resistors are okay. Could have a bad solder joint, but yeah, I think I'm going to go and plug this in, and we'll see what's coming out of it. So as we look at the connector that way up with a little indent here, ground 0 volts is that top right pin, -12 is the top left pin. The shield, I think, is joined to that pin there. The centre pin is -12. Did I say -12 is top left? Top left is +12. Centre pin's -12, and the bottom right hand pin there is +5. So yeah, I might have to use some of those little helping hands to try and measure this. Let's just do the 5 volts first. Want to go from top right here. Let's try not to obscure this. It's super hard to do because I've got to be careful not to short anything. And that one should be 5 volts. Yeah, nothing. Nothing at all. Let's just check that one. Nothing. 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 So it would appear to be completely dead. So just power off, just testing the obvious things here, you know, the switch, it does work. I switched it off and on a few times, still nothing. I did measure that resistor down there, it's like 1.1 ohms it's showing us, so that's okay. We'll just check this other one down here. Sorry you can't see the meter, but yeah, there's one down there. Let's see what that measures. Yeah, 5 point something meg. That's probably the like bleed resistor, you know, a resistor to drain this cap when your power's off. I think because it's magic. It's in the region of mega ohms, but still, I think that's what that is. We could have a problem with this opto here. Maybe it's just completely shutting the power supply down because that's failed or something. That's not out of the realms of possibility, I guess. I can test one or two of these other diodes. You know, there are a number of them. You can see some diodes here. One or two of them might be a Zener. That might be a Zener or something there. Diodes here. We've done the bridge, obviously. There are some transistors, we can test those. But beyond that, my thoughts are maybe the opto. I mean, maybe there's a bad solder point on this. We'll look on the inside of the board in a minute. But it could be one of these small caps here that's perhaps used for the oscillation. You know, if one of these has failed here, it might not be oscillating. You know, it might have one of these turned into a resistor, effectively. Could be something like that. So carefully flipping the board over, and yeah, same warning with all power supplies. You know, you've got a really high DC voltage. If you look at the size of that cap there, it's what's it rated? 385 volts. Because obviously, you know, that's going to be holding DC, you know, rectified DC at mains level. So you know, 300 odd volts in there. In the UK, you know, obviously in other countries it might be a bit less, but nevertheless, if you were to accidentally put your fingers on that capacitor straight after having run this power supply, it will give you an electric shock, quite high DC voltage. There is a resistor there, let's say, to bleed some of that, you know, to suck some of that voltage away, but it would take a period of time for that to occur. You can see the resistor here, you know, we can measure it from the underside. You know, the points are good again, it's just showing, you can't see it, but it's showing 47 ohms. So yeah, those would need reflowing anyway. You can see how it's charred the board there because those have got so hot. I'll inspect a bit closer and clean up this board because you can see look how dirty it is. It's very, very dirty. But I don't think that's the problem. I think we're going to be removing those little caps to start with, actually just measuring them on the meter there. And actually it could be these resistors here. Just look at the circle around those. You know, there's a ring around each of those at that point there. So we've got a cracked solder joint. So those are not, even though they measure okay, the resistors, they're perhaps not joined very well here. So yeah, that could be the problem. I'm going to start by just cleaning up and reflowing that, and we'll just test it to see if that makes a difference. But I will order some capacitors and recap this power supply. So I'm going to use the solder sucker here just to remove the solder. Add some fresh solder containing flux to start with. Sorry, I know we are a distance away there. Just do one point here at a time. You know, heat with some solder and flux. Remove it like that, and then just re-solder it. One thing you can have occur here with these, because obviously this area has been subject to an incredible amount of heat over a prolonged period of time, you may find, if you're not careful, you can lift pads and traces, you know, on those connections there. It wouldn't surprise me. Sometimes you'll have to reinforce with wire. You know, like this part here where these two join, you know, this might come apart. Let me see if I can get you a bit closer. Yeah, hopefully that's a bit better. I just had a little bit of solder and flux there again. Remove the solder from those two pads. Need to be careful, like I say, you can see my hands over the board there, you know, some of the caps, you know, you can get a shock. But I have, and I'll show you the technique. The other thing you can do is just use, you know, find certainly the large capacitor, the one down here. So those connections there. Use a screwdriver or something, or something with isolated handles like this, and just, you know, short over like that. You could then measure volts DC on your multimeter. I appreciate you can't see this, but you can measure across there like that, and that's 0.02 volts. So yeah, there's nothing there, but that's the sort of thing you do before you start trying to solder things here, because all you need to do is just accidentally put your hand across something here and you can get a nasty zap. So yeah, hopefully that's back in position there. As I say, we'll just add some fresh solder and flux. Come on. Yeah, I'm at a funny angle with the iron there, the tip. There we go. Do the same to that one. Try and rotate the iron around. Yeah, I'm not happy with the way those look actually. I might just add some separate flux. Oh, that one's not so bad now, it's been reflowed. Because you'll find that with the pins being heated as well over its life there, it can cause the solder to not join very well. But yeah, hopefully you can see that, that's not too bad. I need to do this one over here next. So we haven't finished, but I'm going to clean up while I'm at this point anyway. Actually, we'll just get a cotton bud here, look at that. Cotton bud with IPA, and just go over this and try and clean the PCB up. Obviously, we need to get the flux and stuff off from around those where we've reflowed them. Yeah, it's going to take me a good 5 or 10 minutes this. I mean, you can see it's just caked in dirt. There might be a conformal coating. Sometimes these things had a conformal coating. It kind of looks like that, but I don't know. This could just be nothing but dirt here. Now look at that. That's horrible. Absolutely disgusting. Let's just see what this area comes up like. Yeah, can you see? Super thick layer of dirt on this. I don't think that's a conformal coating actually. I think that's just dirt. Like 20 or 30 years of use probably. I think it's been in a smoky environment. Can you see it's kind of like a brown? It's awful. Oh, this is really dirty. Just look, it's like, and the thing is, what you don't want to do is just pour IPA and brush this, because it's covered in so much dirt. You have to use a cotton bud with IPA like this to collect the dirt. The cotton bud is collecting it as you're wiping this. If you just poured IPA and brushed it, you're just gonna, you'd be brushing it and brushing it and brushing it for quite a long period of time. You do need to collect it with a cotton bud and periodically change the cotton bud, and then perhaps go over the area you've previously done with another cotton bud in order to try and collect all that contamination. Look at it, it's horrible. So yeah, I'm just going to try and I'll keep it almost flat, pour some IPA over here like this. I'll obviously do different areas of the board here, and I'll do this a number of times. We'll have to do the top side of the board as well at some point, because obviously that's pretty dirty as well, but just to start with I want to just clean up under here. I think while I've got the board out, I'm going to just gently clean over the top side as well. It's not going to be a thorough clean here, but you can see, it is a bit dirty. I think the underside perhaps did have some sort of conformal coating, but I mean, it really stinks this. It smells, I think it's been in a smoky, dusty, dirty environment. I'll just push that from the other side just to make sure it's as flat as possible. Yeah, I'm swapping out two 22s and 22 microfarad, 25 volt. And a 470 microfarad at 16 volt. I don't think they need doing. They measure, let's say, a slightly over capacity, but within tolerance, for the spec of the cap that was on there from back in the day. They were 470, for example, measures about 490. 22 measures about 28 or 29. You could argue it's slightly out of tolerance, but I haven't measured it yet, so I will perhaps try and do that later. But yeah, I'll swap out you can see I've removed the two here. 470 goes here and the 22's there. The negative band goes towards the black line there, so you can see that's the 47, so we'll just do the other two. So those capacitors made no difference. Now I've been listening to this, it's silent, completely silent, and switch it off and on, with your ear really close up to here. Got to be careful, don't do that the first power on, because if something blows up you could deafen yourself. But no sound whatsoever, which I think is suspicious. So I thought we need to, it's almost like there's no voltage, so let's, power it on, which I did, powered on, powered off, very quickly measure the DC voltage here, nothing at all. So this shows the DC is not even coming out into the transistor here from the rectifier. I thought, well, okay, let's step back a track here. You know, we've checked the fuse. So you see this component here, this black component. I think this is like a choke or something, and I think it should short this way. I'm on continuity. I'll show you. I've touched the meter. Yeah, nothing. It's almost like both windings on that have gone. I think that's what the fault is. So yeah, it could be quite challenging trying to find a replacement for that. I'm going to desolder that and just inspect it, but I suspect that's what's wrong with this. I mean, well, if that's gone, something else could have gone as well, but we know the bridge seems okay. There's no shorts on the main switching transistor here, so I'm thinking it's just that. Could have been a spike on the mains or something, I don't know. Something's caused that to go open circuit completely. I mean, I could be wrong here. It looks like the wiring, you know, the live comes in here, and I think it's supposed to go across there, this way, you know, across there. There should be a coil there and a coil there, I think. Unless I'm mistaken and it's not the kind of component I think it is. You know, it could be one of those varistor things or something like that. I don't know. I mean, I could see a current rating on it and a voltage, but I can't quite see the component designation on the board and stuff, and it's not the sort of thing I've had to swap out for a very long time, actually, this. I've certainly never seen that fail on one of these power supplies before like this. Maybe in other equipment, but never an Amiga power supply. Yeah, I think that's majority of the solder removed there. Let's see if we can just free that up. Yeah, it's coming off there. Yeah, it's a little choke, isn't it? Yeah, it's a little choke. You can see there 2 times 39 microhenry. Well, that's good. At least it's got a marking on there. Might be able to find something similar. Now, the interesting thing looking at this, I don't know how well you'll be able to see this. I might put you on macro. Can you see it's like caked in a horrible mucky mess? This is the same sort of stuff that was on the top of it. It's almost like something had leaked into that area of the power supply, and you can't quite see, but looking at the connections that go to the pins here, they're a bit green. I'm wondering if the wire has actually come off on one or both sides. Well, it must be both sides of this. So I'm going to clean that up now with a toothbrush and some IPA, inspect it, and I just see what I can see, I think. Yeah, hopefully this will be visible. Can you see that? It's green here, it's disconnected. So that's that one. This one I think seems okay. If I just rotate this around, yeah, that one seems okay. Obviously, you know, there could be a connection problem further into it, and I think that one's loose as well. Oh, look at that. So there we go. They're both loose. This one's loose, that one's loose. That's the problem. So yeah, if I'm super careful with this, I might just be able to just pull it out a little bit. I can't see it from this distance. You know, tin up the edge. You know, I've got some coil wire of the same thickness. I think what I'll do is just wrap it around it, solder it on, wrap it around this, solder it on, and do the same on both sides. I think we can repair this little choke here. It's not going to affect the inductance of it, you know, too much. Well, it won't affect it at all, really. Just adding a little bit more wire on the end of the thing there, because it's obviously the important bit is the point where it wraps around. It's the number of windings, the length of it, and you know, they're going in and out of the ferrous core or whatever's in the centre there. But yeah, I think we can repair that. You need to think about, you know, the safety aspects of this. You wouldn't want to use, like, I don't know, super thick wire, but then again, it's joining the fine wire anyway. You know, this has obviously got a maximum current rating here of 0.5 amp, but the fuse connects directly to this anyway, so I don't see any problems with doing that. You can see it here. Can you see that wire flowing? So yeah, I'll try and fix that, and I'll show you the results. So incredibly hard to film this. Can you see? I've just joined up this little wire here onto it. So all I need to do now is just carefully wind this around the pin. before I do that, I think I'll cut it off a certain length. We'll heat the end of the this wire here, you know, the enamel or whatever it is on it. It's probably not enamel because enamel's super hard, isn't it? But it's a coating, and as soon as you heat it with a bit of solder and flux, the solder, you know, the coating there just comes off when you get a nice tinned edge. So I'll do that for an extended area up here, and then I'm going to wrap it round that pin and solder it on. But you can see we've got, I don't know, you can see that. We've got the join to the wire there, and I'll do the same thing on the one across here. The final thing to do then is just check that we've got, you know, a short on one, I don't want to break that, a short across two of the pins and the other pins, and they're not joined the other way. Because obviously the live and the neutral, you know, would be shorting if that was the case. So I've done that one there. You can see, you know, I extended the wire out, moved it out a little bit here. So instead of it dead taut, you know, it's got a tiny little bit of extra length, but not a lot. And you can see I've joined the one up here, quite a large blob of solder. I was trying to go for a small join, but you know what, I'm not going to test fate here. And then what I want to do is carefully bend it like that, there, and carefully just bend it around the pin. You can see I can slide it down in a minute, you know, and just keep twisting it around like this. Can you see the end of it is tinned there, but we're just going to wrap it around and round and round, then I'll slide it down so it's flush. You can see we're getting to the exposed bit now, you know, the bit that's tinned. Can't see what I'm doing here. Yeah, you can see it's just going around, and then we can use some super fine nose pliers here just to help get that around its last few turns. There you go. Yeah, that's on. I don't know if you can see that. That is on, and we can slide it down like this. Get it as flat and as flush as possible. Just get some solder containing flux there, and hopefully it won't detach from here. We'll test that in a minute. But I have just tested the winding over here, and I think it shorts this way, so that's working. So we just need to make sure they're not all shorting. We should just have a short between two separate pairs there. Anyway, I've got some solder and flux on that now, and we'll test it. So finally we can test it. So if I measure from the top left pin there to the right, should be nothing. Yeah, see, open circuit, nothing. One down here, I don't know, you can hear that for the rain, but you can see it's going to 0, 0, 0, got a short there. Test to that one, nothing, that's correct. So if we just rotate it around, we'll do the same thing on the other two contacts there. Nothing across there. Hang on. Ooh. Yeah, short there, so that's good. We've got short, you know, across there, and nothing to here. So the repair looks okay. It's just a question of the that bond wire there, you know, the transformer wire there. Is it about the same thickness as the wire that's already there? It kind of looks it. It might be a tiny bit smaller. The other thing is something could have caused this to pop. So you never know, it might just break again, but I think not. I think you saw the state of this. There was loads of corrosion and stuff that got on the underside of it, and it was all on the outside. I cleaned that previously and didn't think much of it until eventually I worked out that this was open windings here. So I think it's just corrosion. I think some corrosion's got on the board and it's just eaten away at the points where the bond wires join the pins here. So we'll carefully get that back on and go and give it a try. So it's back in place, and if we just measure across this way, sure, you can see that. Yep, so that's like the neutral, the negative, you know, the neutral. This way, you know, between live and neutral, nothing. Live and neutral, nothing. And then this is the live, this comes through the fuse here. So the fuse is the first thing in the chain here. As you can see, short. So I think we're good. Let's go test this. Hopefully it won't pop. If it doesn't pop, then it will be a pretty short repair. Ultimately I will swap out these caps. I'll order some of those. So yeah, let's go and give it a try. So I've got it loosely reassembled there, and I'm going to just plug it in now. Hang on. Hope it doesn't bang. It's already on. So yeah, I'm not sure. I might be able to hear it oscillating now actually. So I've moved the thing around there just so you can see a bit better. It's going to be super fiddly to measure this. I've got to try and, well, not short anything, not just try, do not short anything, because I'm either going to blow it or something like that. Hang on. Hey, you can see that? 5 volts. Oh, hang on, I'm shorting something here, hang on. Look at that, 5 volts. Bouncing all over the place, that might be because there's no load. We've got the minus 12 there, and plus 12's up top left, isn't it? Yeah, the plus 12 is a bit high. I'm going to just try that under load on a faulty board here that has just some 7.4 series logic, and this will be a future repair. You can see it's missing loads of chips, it's got broken sockets, it's got capacitors missing, it's got traces broken. This was one that was donated by Anthony over at RRG actually. I think he bought it in that state and just used the board for spare chips that were already remaining on there. So I've got it plugged in. Yeah, I shouldn't be doing this on a carpet, but as I say, that board has nothing on it. There's just like, I don't know, 3 or 4 or 5 maybe TTL chips. So, and I think ultimately they're going to need to come off anyway. So all I'm using this board for here is just to measure the voltages. So yeah, you can just about see the meter there. Get that on the ground down here, I think, and we'll have a look. See what we've got, if anything. Is that a ground? Yeah, there's a ground. So you can see now with a bit of load, the 5 volts is stable, 5.3 volts. That's ground. What's that one? Minus 12. Yeah, a little bit low there, but that's okay. And plus 12, again, a tiny touch low, but that's okay as well. So I think this power supply is fixed. The next thing I would do is obviously recap it. So I'll do that now. I'll go away, measure up the caps, and order some replacements for those that I don't already have in stock. Just quickly trying to do this before it goes flat. Watch this, that capacitor. See the voltage there, 0.65. It's going down, 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 gradually, slowly there with that resistor over it. Previously, like I said, there was nothing. That was the clue to me. I needed to check the actual mains input on the bridge side of things, because that capacitor, should get the rectified DC across it. So it would be very high, 370-ish volts, It's like 240 times 1.414 recurring, effectively. Is that right? Yeah, I think it is. So the fact there was nothing there, that was a clue to me that actually we're not getting any mains into this. The mains is, getting cut dead in its tracks kind of thing. So that was why, ultimately we looked at this component here. So I've got some 4700 microfarad caps here. They're a slightly higher voltage. They're approximately the same size, ever so slightly bigger, as you can see, but we can fit those in there. I've got 4 of those. They're Forever, yeah, so not an amazing brand. I'll order some Panasonics to replace these with, but these are good caps. I've used these in a number of places. So yeah, I'll swap these 5 out here. This one I'm going to order one for. I might not cover it in this video, but I will order a replacement for that. Again, I'll try and get Panasonic. But these should be fine. They are good, these Forever ones. So I'll just show you me removing the last 4700 here. I'm using the desolder station here. Add a bit of solder and flux just because you get a better flow that way. Yeah, wait for it to go molten. You can feel it moving. You can see that's one done. Sorry, moving out of shot here, aren't I? Add a bit more solder. Again, just have a wobble around. I can feel the caps loose. There we go. So yeah, the station I've set to 430 because these massive tracers here absorb tons and tons and tons of heat. So yeah, you'll need a pretty beefy soldering iron to remove those caps from this side here. So I'll get the last 2 on. I should be doing this on the ESD mat really. You do risk some ESD damage to the silicon devices and stuff on here, but you can see the band, negative band goes towards the black line. These capacitors came from, they belong to Alison Shallis actually. Mentioned Alison lots of times on my channel. If you want to know more about Alison, check out the video I did creating Alien for the Atari links there. It's a piece of homebrew that I developed myself based on the C64 version of the game. And yeah, I did that in memorial to Alison. I'm still close friends with Colin actually, Alison's partner. Play usually online with him every night on the PS4, and his son Nathan. Yeah, he's a great lad, Nathan. You can see it's absorbing lots of heat, that. But yeah, we got there in the end, so we'll just trim those off. The final thing is just to clean up with cotton buds and IPA. So yeah, I'm not going to bore you with all of this, but we'll just go around to each of those points I've reflowed there, including the choke. So I washed the case parts in the sink. I need to use some plastic cleaner or some IPA or something to get some of these cable marks off. You can see here, you know, there are marks all the way around it. It still looks a bit dirty. Soap and water does not always clean these things up particularly well. There's still the odd bit of, I can see it there, a bit of water in the thing. So yeah, we need to do a bit of this, I think. But yeah, it's been drying for a while now. You can still see it looks a little bit dirty in corners and things, but yeah, most of the dirt is out of there. The board it's not perfect, you know, but it's as clean as I'm going to get it, I think. You can see as I was doing these, I marked them up with a little red mark on top, so you can see all of them apart from this one have been done. I'm going to go and order one of those, 47 microfarad, 385 volts. I suspect you probably can't get 385 volts. It's going to be 47 microfarad, 400 volts. Is going to be the nearest. Yeah, and needs to be quite thin pins as well there, actually. But you can see, you know, I removed all the flux from the caps that have been swapped out there. There's no other bad solder points. That doesn't look so clever there, but actually it is. It's just the way it's mounted on the PCB. So yeah, we'll get this back in there. I think it goes this way, doesn't it? Yeah. And you can see there's like little cutouts for the posts at the bottom. So yeah, that sits like that. That slides into there. This slides there. The thing I've never really liked about these, the way the switch, you know, it just slots into the channel here. So, you know, it could come out. You need a fair bit of force to pull it out, but yeah, as you can see, that really is it. So I'll get the screws back in and we'll just get some IPA or plastic cleaner onto these marks to see if we can clean it up some more. So some people, including me, use these on other Amiga machines, you know, not just the 500 or 500 plus that this was perhaps shipped with. You can see the voltage and current ratings here, 5 volts, 4.5 amps, that's pretty beefy. 12 volts, 1 amp, that's not too bad, minus 12 at 0.1 amps. I think the only thing that uses that, maybe some of the audio circuitry on there, I don't think so. I think primarily it's used by the serial, you know, there's a, I don't know, 1488 and a 1489 or something similar on the board there, you know, a transceiver and or a transmitter and receiver type ICs, and those usually need minus 12, I think. I'm not sure if the floppy drive might use minus 12, I don't think so. It usually just uses plus 5 and plus 12. But one of the reasons I like these, you know, compared to going out and buying a replacement power supply, is it's off the shelf parts. These things are really robust. You know, if you recap one of these, it could last you another 20 years, and it's, again, it's off-the-shelf parts. You're always going to be able to find equivalent parts, unless the transformer dies, you get, or one of the ICs on there. You're always going to be able to find generally replacement parts for these. So yeah, they can be a bit fiddly to work on, and as I say, you've got to take safety seriously when you're working on any power supply. You could easily electrocute yourself, you know, because you've got very high DC voltage on the switching transistor there, and the caps will hold charge as well. But if you're careful and you know what you're doing, there's no reason why you can't repair most of the ones of these that are out there. As I say, where those two resistors were, you know, the board was a bit charred, often those will burn up. So it can be difficult sometimes if you get one and both of them burnt up, understanding what size resistors go there. But as you saw on this one, the two were both 47 ohms, I think, on this particular power supply. So we'll try some IPA on there. It might not shift these marks. I mean, nothing might shift them. They might be permanent marks in the plastic. Yeah, you can see they're kind of like scratched, aren't they? I might just try a bit of Plastex. Can you still see? We've still got a couple of marks there. So take two with a bit of Plastex. Let's see if that'll shift them. Possibly not. Yeah, I think they're kind of permanent marks in the plastic, aren't they, rather than dirt, because you can see that's made no difference to those ones whatsoever. Yeah, these marks aren't coming off. You can see the kind of, you know, it's like a melt or a scratch into the surface there. So yeah, I mean, you could retro bright this again, you know, to make it less yellow, but I don't see the point. It's just going to sit under a desk somewhere. You know, it's going to be out of view, really. We can just clean the cable up here a bit, see if we can get some of the marks off that. So I've done all my usual crazy OCD. You can still see it looks a bit dirty, but I have cleaned up the plug, cleaned up the contacts here with a fiberglass pen, you know, so they're as clean as they possibly can be. Cleaned up the other side of the cable. I've just cleaned the shielding part around there, but I don't know, you can see it's a bit dirty in there. You know, there's some particles of dirt. I don't know whether it's been in a stud in a shed or something by the looks of things. That might be how that corrosion's got onto the choke. But yeah, just dipped toothbrush in some IPA, and I'm just going to give these pins a bit of a clean like this actually. Yeah, you can see, you can just about get a con bud in between the pins there. And just look at that. That's disgusting. There is a lot of dirt in there. Another way to clean something like this, you know, if you want to be super sure it's clean, get some deoxit or something, you know, switch or contact cleaner, spray it in there, and then insert it and remove it into the motherboard. You know, I don't know, a good dozen times or so, and that can help as well. Yeah, that's not too bad. I managed to get most of the dirt out of the cavity there. So if you look past the Archimedes keyboard here, there's the power supply plugged into my 1200. So yeah, this was previously retrobried. You could argue it's gone, you know, it's got a cream, very light cream tinge to it, but this was done 5 or 6 years ago now, this 1200, and it's held up very well. The composite never looks very good, but let's just try and load a game. It's working fine. Fantastic. I think we can call that a success. So I've connected up my arcade stick actually, the Neo Geo arcade stick here. I've got an adapter that I showed in a previous video. I think I'll perhaps have a play with this for a few hours, see how I get on with it. Yeah, I've been testing this power supply for an hour and a half, no issues at all. It's sweet. It runs at a fair speed on this version, doesn't it? Forgotten how fast he ran. It's actually too fast, but then again, it's because of the CPU's running at 33 MHz, I think, in the system. There we go, baseball cap. When you get the baseball cap, it means you can collect the little baby ghosts that get dropped on you as little bombs. I've lost it now. So I think I'll just label this up before I forget, just so that it's a reminder that this one has been recapped actually. You know, they're going to, some of them obviously have mine, have not recapped. This one has been recapped. So I've tested some of these on my other cap meter, and yeah, they're coming up higher. You can see 26.92 and ESR 3.8. I mean, it's saying it's okay. 3.8 seems quite high resistance to me, but nevertheless the small caps. Yeah, it's super hard to use this cheap tester because you've got to get the pins into the holes properly. So I think that one's a 470. Where's the test button? You could see there it came out 570 or something, yeah, with an ESR of 0.4. So yeah, that appears to be okay, but you know, the capacitances are a bit off, but that's what you kind of expect for capacitors of this era. I don't know what the tolerance was on them, maybe 10%. You see that one's similar, 540 microfarad 0.4. Yeah, these ones are going to be harder to test because I ain't going to be able to get the pins to stay too high. The interesting thing with this one is it's off the scale. Maybe it can't read 4700 microfarad capacitors. And testing on another cheap tester here, you can see, you know, it's getting the capacitors almost right compared to my other meter. It's showing the voltage loss is 2.8 to 2.9% on each of these large caps actually. Let's try that one. It's saying the battery's low, 6.79 volts it is, and I've just measured it. It's not very accurate in terms of it measuring the voltage under load there. Yeah, 2.6% on that one. But this one will, if I put it onto the 20 meg range, it's going to come up 4 point something probably. So bear in mind these are 4,700. So you can see, yeah, that one's under capacity. Instead of 4,700 we're getting 4,390, 380-ish. So yeah, I think these needed doing. I think the ESR's alright on them. Got that around the wrong way, haven't I? Some of them are better than others. You can see that one's pretty close. That's yeah, 4,900, isn't it? So it's going to be within tolerance. You can see they also used 85 degrees C caps on these. I've put 105s in, I think. I could be wrong, I think I have. I think most of my caps tend to be 105. I don't bother with the 85 degree ones. Again, slightly less, not a lot less, but nevertheless it is. Let's do the last one there. Yeah, that's not far off, that one. It's jumping around a bit. It could be that the probes are wobbling around on the contacts there, but yeah, that one's not far off. So 3 of them were perhaps not very accurate there, but as I say, they were going to be like that brand new probably. The tolerance on them. That one's a 470, I think, put it on the 1,000 range. Yeah, that's a 470, so you can see that was very close to what it should be. That's another 470. Yeah, a little bit higher, but you know, again, it's going to be probably within tolerance. And the 22s measure between around 25 and 28ish or 29ish. I think one of them measured before, can't remember. Let's just do the other one. Yeah, about 25 again. So again, it's perhaps within tolerance. So I think the ESR of all of these are probably okay, and the capacitors are all right. They're pretty tolerant Amiga power supplies. I've got 5 of these now, and the other 4 don't need recapping. You know, and they're 30 years old. They've had an awful lot of use, and they're fine. But you can do for, you know, maintenance, you know, to keep these things running for longer and stuff. And obviously, it's perhaps better on your Amiga. The last thing you want is some bad caps in there at some point to get a dirty supply line going into the Amiga that could contribute to a fault. So recapping them as a course is a good idea anyway. Yeah, so I'm fine with that. It's been running for 2 or 3 hours, no issues at all. I do hope you found the video interesting. Please like, share, subscribe, and I'll catch you in the next video.